Now, hello, good morning. Now we know the closure of the either end of a cylindrical vessel is known as its head. Okay, so head can be of two type mainly. The simplest one is a flat head. Okay, just a circular plate whose diameter is equal to the outer diameter of the cylinder, and that can be attached with the cell by the welding or using the flange also. Welding joint is used there where where there is no requirement for the opening the end. Now there are another type of heads, okay, that is known as the formed head, and some curvature, okay, and the some curvature is there in the head. Now you can see here, this is a cylinder, and you see here the top, it is nothing but a head. Okay, now you see that is a dome side shape, and it is the diameter, outer diameter is equal to the outer diameter of the cylinder. And other type of the formed head is of the toruspherical head, ellipsoidal or elliptical head, hemispherical head. Okay, and there is a disc and flanged head. You see here, there is nothing but a flange, and this is a disc head. So different type of heads depending on the pressure requirement we need. Now if you see this figure, okay, this is the order formed head, that is the ellipsoidal or toruspherical, hemispherical. Hemispherical is a perfect hemisphere having the diameter equal to the diameter of the shell. Now you see that in any formed head, okay, have a disc with a fixed radius. So you see here, suppose this is a disc. Suppose this is a disc, and if you if I truncate it from here, if I truncated the disc from here, then it will be like this. Sorry for the figure. So any formed head have a disc with a fixed radius, and that radius is known as the crown radius. Okay, that radius is known as the crown radius. And the transition between the cylinder and the disc, now you see here, this is the cylinder, okay, here is a cylinder, and this is the disc, crown radius here, and the transition zone means here, here and here. This is the transition zone between the cylinder and the disc. It is known as the knuckle, and its curvature is different from that of the crown radius. And the radius of these sections is known as the knuckle radius. Kr equal to nothing but the knuckle radius. Knuckle. So knuckle radius and crown radius. So any, I am repeating, any formed head, not flat, has two portion. One is the disc portion, which having a radius known as crown radius, and at the transition point, okay, at the transition point of the cylinder and the disc is the curvature is different, and this curvature or this portion is known as the knuckle, and the corresponding radius of this curvature is known as the knuckle radius. Now you see there is no knuckle radius in the hemispherical head. Okay, all are the radius, okay, of the sphere. But for the other type of heads, formed heads, elliptical or ellipsoidal, toruspherical, here you see the conical, okay, shallow disc, okay. So all have two radius. Now, depending on this, on the values of these two radius. Now, if I switch back to my original PPT, I'm stop sharing it and if I share it now. So this is the head and not like this. Okay, this is the knuckle portion. And if now if the heading flanged and shallow disc and toruspherical head. Now, while pressing into disc shape, okay, such heads consist of two radius, what we have already told, that is the crown radius and knuckle radius. Now, if the crown radius, I am writing here, if the crown radius value is more than the cylindrical cell outer diameter, then the head is formed is known as the flanged and shallow disc. The head is flanged and shallow disc head. And if the crown radius of the head is less than equal to the cell ID, sorry, cell ID not cell OD, then it is known as the flanged and standard disc head. Flanged and standard disc head, which is known also toruspherical head. Toruspherical head. Okay, so if the crown radius is greater than the cell OD, the head is flanged and shallow, and if it is less than equal to the cell OD, then it is known as the toruspherical head. Now, you see here, due to this knuckle portion, what is that? That is the small inside corner. It is the knuckle. That is a very small inside corner. Okay. Now, here is an abrupt change of the curvature. So, the localized stress here is the maximum value. So, the maximum stress will be at the knuckle portion. Next, now to increase to increase to increase the pressure rating of flanged and disc head. Okay, flanged, this is known as the flange state. Simple. Okay, it is fitted with the cylinder, and the D state, formed and D state. Okay, so the local stress the local stress at the inside corner, that is at the knuckle, at the inside corner of the head, you keep writing, of the head, must be reduced. So must be reduced because there is a sudden change in the directions. Okay, so pressure was applying like this, but here there is a sudden change in the direction. So the localized stress or the resultant stress value may exceed the allowable stress of that material. Okay, so due to the changing, not only the hoop stress but the bending stresses, okay, and other some localized stresses may be generated there. Now, what can be done to reduce the corner stresses? So, this can be achieved. This can be achieved by forming the head with knuckle radius, which gradually changes the direction, not the abruptly knuckle. Okay, with knuckle radius not less than not less than 3 times the metal thickness and also not less than and all this is the thumb rule, also not less than 6% of the inside diameter of the inside diameter. So this is the thumb rule to make the knuckle portion. Now if we see the how to determine the thickness of the different heads. Okay, so for the shallow disc and spherical head, sorry, you write down, keep writing. The thickness of the such head the thickness of such heads is H for head. It is the where you know these values RC equal to crown radius, W equal to stress intensification factor, stress intensification factor, and the value of that how to determine this is 1 upon 4 3 plus crown radius by Ri R1. R1 is nothing but the knuckle radius. It is the knuckle radius. So if you know this value, then you can find other. J is nothing but what is J? What is J here?
Joint efficiency.
Joint efficiency 0.85, 0.9, whatever it is. Okay. And for conical heads, okay, for conical heads, for conical head, we can find the circumferential stress using these equations PD by 2t cos alpha. Okay, what is alpha? Alpha is not the half of apex angle. half of apex angle of the cone. So it is look like this. So this angle, apex angle, and half of that is the alpha. And alpha, and the thickness is that for the conical th equal to pd 2fj cos alpha. So this is the thickness. Now for the case of the elliptical head, and this is specific for the semi ellipsoidal, the thickness is determined using this, where d is the major axis of the ellipse, major axis of ellipse, not diameter. V is again the stress intensification factor, stress intensification factor, and the value is for semi-ellipsoidal 1 upon 6 2 plus k square. What is k? K is nothing but the ratio of major to minor axis. Major axis divided by minor axis. Okay. And for semi-ellipsoidal, major to minor axis ratio is 2:1. Okay, that means what is that meaning semi-ellipsoidal? The width of the ellipse, the width of the ellipse the width of the ellipse is twice the depth. What is the meaning? Suppose this is the ellipsoidal head. Okay. So this is the width and the depth is here. Major axis, minor axis. So it is a dome shape. Okay. I'm writing in 2D, but it is a dome shape. So it is the ratio of the width to the its depth, 2:1. Or it can be written as also the height of the head is just a quarter of the diameter. It's just a quarter of the diameter. And for the semi-ellipsoidal, the value is the 2. And for the elliptical head, generally K value should be less than 2.6. If it is not ellipsoidal, although the value should be, or construction should be such that the major to minor axis ratio less than 2.6. Next is the hemispherical head. Hemispherical head. Hemispherical head. For the hemispherical head, the calculation is very easy. That is nothing but the ED. D is here, the diameter, 4FJ. So what is the, is it a hoop stress or axial stress? Which one?
Axial.
Axial stress. Hmm? The radius of the head, the radius of the head equals the radius of the cylinder, of the cylindrical part of the cylindrical part of the vessel. And since here no knuckle portion is there for the hemispherical head, and a guided gradual decrease of the diameter. Okay, so from the every side, this is a 3D picture from the every side. So the localized stress does not form, and they are most strongest head because no localized stresses develop, and the even distribution of the stress at the junctions of the head and the cylindrical part for the hemispherical head, but the constructions for big hemispherical head is very costly. So that's why, unless required urgently or essentially, we don't go for the hemispherical head. Now, just for your curiosity or just for your knowledge, I will show a video where you will see how a formed head is prepared or construct or fabricated. So I am stopping sharing this and I will show the video. Let's see. You see here how it is. Can you see the video? Now, is it? Is it visible?
Yes, sir.
So you see here, this is nothing but a red hot flat circular plate. Now we will shape into the formed head. Now it is a just circular red hot plate around temperature 1500 degrees Celsius like that. Now it is put in the mold. Still now it is a flat circular plate, and when it will be pressed by the upper pressing object, okay, the diameter of the formed head will be definitely less than that of the flat plate. You see here, now it will be pressed.
Sir,
Huh.
sir, the man was measuring the temperature.
No, 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 no. Maybe for cooling purpose they split some the oil, okay, for the cooling purposes or not for the friction purposes, okay. So this man may be done that. You see there is a pipeline and there is a suction, okay, and they may, using the suction pipe, they may collect the iron dust. Now again it will be pressed. You see there, using that they are cleaning the iron dust or some dusting. And since there is a oil, okay, and the high temperature, so it is burning. So for the lubrication purpose, they may use the oil, because water will evaporate or vaporize at 100 degrees Celsius, and you are using almost 1500, 1600 degrees Celsius. So oil is needed. So you see that the flat circular plate is now converted to a formed head, and you clearly seen that there is a two radius, round and knuckle. So this is the procedures for the making or manufacturing the formed head. Too much costly for the different size of different diameter of heads. You have to prepare different mold, very costly. okay, to prepare the mold perfectly. So, and that's why the hemispherical head has become very costly. And we use a standard diameter for the different cylindrical head, different cylindrical vessel. Otherwise, different type of heads should be there. It is very tough. So it will be better to prepare a standard value or use the standard diameter. So this is the case, and we have just know the expression for estimation of the head thickness, and the cell cylindrical cell thickness need not always to be equal. Most of the cases head should be a thicker, okay, to handle the localized stresses. And the most weakest portion of the head is this, at this knuckle portions. If some crack or the material failure occurs, then the knuckle portion is the most prone for that. Anyway, next day we will start some problem. Okay, now we have done the theory, and we will try to solve some problem. And you can see, and you can see the book, the, for the more information about the head. You can consult the book of the Joshi. Soft copy is available. Okay, or any standard book. There are some problem also. If you see the how to solve this problem, then it is also benefited for you. Anyway, so what is the total number of students? 103, and the total strength is 114. कौन नहीं आया? ठीक है. Roll number 1, 2,
Present, sir. Two present, sir.
4, 5,
Five present, sir.
6,
6 present, sir.
7, 8,
Roll number 8 present, sir.
9, 10,
10 present, sir.
11,
11 present, sir.
12,
12 present, sir.
13,
13 present, sir.
14,
Present, sir.
15, 15 नहीं है, 16,
16 present, sir.
17,
17 present, sir.
18,
Present, sir. 18 present.
19,
19 present, sir.
20,
20 present, sir.
21.
21 present, sir.
अच्छा, 22 से 25 कौन कौन है बताओ?
23, sir.
24, sir.
23, 24 बस. 26 to 30 कौन कौन है बताओ?
26, sir.
हाँ,
28, sir.
okay,
29, sir.
30, sir.
all present. 31 to 35 में कौन कौन है?
31, sir.
32, sir.
Okay,
33, sir.
fine.
34, sir.
And 35 नहीं है. 36 to 40 में?
35, sir.
36, sir. Okay,
37, sir.
बताओ फिर.
Sir, 38, sir.
39. Okay,
40, sir.
41 to 45.
41, sir.
हाँ,
43.
43. Okay,
45.
45. For then 46 to 50.
46 sir.
47 sir.
ठीक है
48 sir.
ओके
49 sir. 49.
50
50 sir.
ओके 51 to 55
51 sir.
बताओ
52.
नेक्स्ट
53 sir. 53 sir.
54 sir.
55 sir.
56 to 60
sir.
ओके
58 sir.
ओके
59 sir.
ओके
60 sir.
57 बस नहीं है ओके 61 to 66
61 sir.
ओके
52 sir.
63 sir.
65 नहीं है 66